When we're designing class hierarchies, it's important to understand the difference between something that's called an abstract class and something that's called a concrete class. Okay? So, when we were working with the employee class, for example, is it true that everything that we had was a subclass of employee? So, for example, I think we had hourly employee and salary employee. Okay, so these were two classes that extended the employee class, and then there were two classes, I think at least, that extended these. So, for example, I believe it was we had manager, and then we had, I think it was sales associate. It's actually been a couple months since I recorded the last video, but I'm pretty sure this was the example that I used. So we say that sales associate is an hourly employee, which is itself an employee. Okay? But one thing we should kind of notice is that, is there really such a thing as just an employee? Like something that is, in and of itself, just an employee and nothing else? I would argue, in this hierarchy in particular, the answer is no. There's nothing that is itself an employee. So what that would mean is that this employee class should be labeled as abstract. Okay? So that example, or at least this definition of it, might be a little harder to understand. So let's go with the canonical example of abstract versus something called concrete classes. So the traditional example is, let's do this in IntelliJ actually. So the traditional example, and the one that's used over and over, is that we have a class that's called animal. Okay, we have a class that's called animal. So let's see if I can make this just a little bit bigger. Zoom in. There we go. So yeah, we have a class that's called animal, and let's say that it has a method that's called speak. Okay, and we'll just say that for an animal, it doesn't, it returned nothing, right? It can't speak at all because it's just an animal. But let's say that we have a class that's called cat that extends the animal class, and it overrides the speak method by returning meow. Okay, just something very straightforward. And then let's say we do the same thing for dog, and this extends animal, and we override speak by doing return wolf. I don't know, just something that polymorphically changes the behavior of speak. Okay? Now, here's the thing. Let's say that we're going to test these classes. Like, let's say that we're going to create a list of animal objects, like that. Now, as we know, because cat and dog are kinds of animals, we can create, or we can add, rather, to this list of animals, subclasses of animals. So, for example, we can do, like, new cat, and then, new dog, and then we'll do new cat again. And then, if we want to, let's say, call the speak method and print that out to the console, you can do something like for animal A of animals, and then system.println a dot speak. Okay, so this should print meow wolf meow. But I mean, this really isn't anything special. I mean, we've kind of done this before with interfaces and the employee class hierarchy. So that's not really the special thing here. What is special, or what we're going to do that makes this special, is we're going to say that, or at least we're going to think about this for a little bit. We're going to say, is there anything that is in and of itself an animal? Think about everything, perhaps in the world. I don't know if you want to consider more than just the domain of what we have here. Is there anything that is inherently just an animal and nothing else? I would argue that no, there's not. The same thing with the other example with the employee class. There's no one that is just an employee. Rather, every employee is a kind of employee. And the same thing holds true here. We have an animal class that everything extends. Well, maybe not everything, but anything that extends animal is a subtype, a subclass of animal. But there's nothing that, like, for example, we wouldn't do something like animal A equals new animal. Now, we can do this. This is allowed by Java because we haven't declared the class as abstract. But what exactly does that mean? What that means is that animal is just an abstract I'm using the definition. I'm using the word in the definition, but it's just bear with me. Animal is just an abstract representation for other classes to extend. Okay? You can't instantiate an animal directly because it doesn't make sense to do. Right? It doesn't make sense to create something that is in and of itself an animal, and I think most people would agree. So what we can do is declare the class as abstract, and what that will do is that will prevent us from creating an instance of the animal class, because it will say it's abstract and cannot be instantiated. And again, hopefully the intuition behind that makes sense. Like, it's just a representation and not something that we can create. Everything that we want to create that is an animal needs to be a subtype, a subclass of that object. Okay? So we can do animal ANAD equals new cat, new dog. You could also do cat C1 equals new cat, dog D1 equals new dog, but there is a difference, and we'll talk about that probably in the next video. But for now, the last thing I want to demonstrate, well, there's two things actually. One of the last things I want to demonstrate is this notion of something called an abstract method. So because animal's abstract, does it really make sense to have a speak method? What we want is for subclasses to give an implementation to the speak method. So that's what we do. We override the speak method in both of these subclasses. So if we have an abstract class, we can make a method be declared as a... Sorry, I had a timer there. We can declare a method as abstract, and that will mean that we don't give it an implementation inside of the abstract class. Rather, it's the responsibility of the subclasses to give an implementation, which we have done here. Okay? Now, this sort of brings up a debate of, why couldn't this just be an interface? We haven't done anything here that really showcases that this is any different from an interface. And indeed, that's kind of true. We haven't. But consider the example with the employee class hierarchy. I don't have it right here, so I'm not going to pull it up. But the difference between abstract classes and interfaces is that, for one, a class can only extend one other class. Classes can implement many interfaces, so they have different responsibilities. Second, an interface is used for describing behaviors of a class, not necessarily properties of the class. An abstract class, rather, is used for describing a reference sort of abstract concept for other classes to then extend. This can include behaviors and properties like instance variables and things like that. You can't have instance variables inside of an interface because it doesn't make sense to. Additionally, with an interface, methods must be public, or rather they are implicitly public. Abstract classes don't have that restriction. Moreover, an abstract class, you can have methods that are non-abstract. So, if we wanted to have another method like void eat or something, and maybe this just does something in the animal class, we don't have to make this method abstract. If you have an abstract class that has an abstract method, then the subclass, if the subclass is not abstract, it must provide an implementation for that method. Now, what we could do is have an abstract class that extends another abstract class. For example, we could do employee, and then have, we said hourly employee and salary employee, but I would argue that even these are just abstract classes themselves, because these are then implemented by the sales associate and the manager classes, and then maybe this one would have another subclass beneath it, like assistant manager or something. But these two, I would argue, would not be abstract, but these three would be abstract. And if we had a method inside of employee, like work, that was abstract, these two classes would not need to provide an implementation of it, although they could, but these classes would need to provide an implementation if these two classes, those being hourly and salary employee, did not provide an implementation. Okay? So, one last thing. If we have a class that we don't want to further extend, we can mark it as final. Okay? So a final class is just a class that cannot be extended, and that that kind of makes sense. Sometimes we don't want a class to be extended, and you can do that. You can also make a method final. If you make a method final, it means that it cannot be overridden in a subclass. Okay, and in my book there are some exercises, or at least there's at least one or two, where you need to write a final method in order for the implementation or the exercise to make sense. Okay? So in this video we talked about abstract classes, we talked about, so one thing I will say is that classes that are not abstract are called concrete. So I said that at the very beginning of this video. So there are abstract classes and there are concrete classes. Okay? And we also talked about the difference between abstract classes versus interfaces. We talked about final classes, we talked about final methods, and yeah. So, in the next video we'll do a little bit more work with abstract classes.